Hello, my name is Serhan Efe. I am student in the Electrical and Electronic Engineering at Bilkent University. And in this video, I am going to present my PHYS-101 lab experiment about rolling cylinders. The main aim of this experiment is to study how the moment of inertia affects rolling motion. I compare a solid cylinder and a hollow cylinder that have the same mass and the same motor radius, and I investigate why one of them reached the bottom of the ramp earlier than the other. Now I will quickly show the equipment I use. Here we have a ramp. Its length is 1 meter and it is set at about 45 degrees to the horizontal. These are the two cylinders. This one is solid, this one is hollow. To measure this reading more accurately, I use a vernier caliper. Both have a mass of 0.5 kilograms and an outer radius of 0.05 meters. The hollow one also has an inner radius of 0.04 meters. I also use a ruler to check the ramp length, a tool to set the angle of the ramp, and a smartphone camera to record the motion and later measure the time. Here you can see how I do the experiment. I put the solid and hollow cylinders side by side at the top of the ramp. I release them at the same time and I don't push them. They start from rest and just roll down. At the top, both cylinders have gravitational potential energy MGH. As they roll, this energy changes into translational kinetic energy 1 over 2 mv squared and rotational kinetic energy 1 over 2 I omega squared. The important thing is the moment of inertia. The hollow cylinder has a larger moment of inertia, so more of its energy goes into rotation and its linear speed is smaller. That's why you can see that the solid cylinder reaches the bottom first in the video. Now I will show the tables and graphs from my report. As you can see in table 1, this is a summary of the basic physical parameters. Both cylinders have the same mass and the same motor radius, and the only difference is that the hollow cylinder also has an inner radius. As you can see in table 2, these are the theoretical final speed and kinetic energies. The solid cylinder has a higher theoretical final speed and more translational kinetic energy, while the hollow cylinder has more of its energy in rotation. These values are calculated using the energy conservation equations and the rolling condition that I explained in the report. In table 3, you can see the experimental results from the video analysis. Here we have the measured time, the experimental acceleration, the final speed, and the kinetic energies. Again, as you can see, the solid cylinder is faster than the hollow cylinder. In table 4, we have the percentage error between the theoretical and experimental values. As you can see, all the errors are not very large, which is reasonable because we have effects like rolling fraction, air drag, small difference in the release, and some uncertainty in the timing from the video. Finally, the bar graphs in figure 1 to 5 show the same information in a visual way. Figures 1 and 2 show the theoretical speeds and energies. Figure 3 and 4 show the experimental speeds and energies. And figure 5 show the percentage errors. As you can see, the graph clearly compares the solid and hollow cylinders and support the same conclusion. In conclusion, this experiment shows that it is not only the mass that matters, but also how the mass is distributed. Because the solid cylinder has a smaller moment of inertia, it speeds up more and reaches the bottom first. The hollow cylinder has a larger moment of inertia, so it rolls more slowly. Thank you for watching.